Question: which piece of information is most relevant to gather from a customer interested in going solar? Would that be A, demand charges, B, energy charges, C, meter charges, and D, total utility bill charge? So let's check this out. 16. We're looking at what piece of information is most relevant for somebody going solar. And so the way that I'm going to look at this is somebody is going to get solar, not energy storage, not electric vehicle, not anything but solar. So which one of these things is solar going to help with the most? And so let's see, remember demand charges, that's a power charge. Energy charges, that's an energy charge, like kilowatt hours, power times time is energy. Then we have meter charges, and meter charge might not say meter charge on the bill, but it's a charge for being connected to the utility, just for being there. Even if you're not home, even if you turned off your main breaker, you get a meter charge. We used to say it was for the meter reader, but now we have smart meters. And then the total utility bill charge would be all of this stuff. So let's go look at some sample bills here that I just kind of pulled off the internet. You can see this one came from an article in Renewable Energy World. ABC Utility Company sending out a bill for $8,000. So that's probably not somebody's big house, even though I've heard of people having crazy air conditioning bills. I've got a friend that's got 13 bathrooms. A nice house. You got a pretty good deal on it too. And so let's see, we're looking over here and we can see it's got two different meter numbers. Looks like one of these is for demand and one of these is for energy. So there we see demand. It's got peak and off peak, 500 and 150 kilowatts. And so look at that. That is a rate of using electricity, typically in 15-minute intervals. And it's not an energy charge. You can have a high demand charge and just use a whole lot of electricity all at once for 15 minutes in a month and have that be your demand charge. And then we could see that there is quite a bit of kilowatt hours used here. So there's 43,000. And just to put that into perspective, your average residential customer uses about 10,000 a year. So this is in 31 days, they've used as much as 4.3 houses use in a year. So it's a business. Businesses are big, and we don't want to penalize people for having good businesses. Now we're going to go here. This is the fixed fee. Remember, basic charge, fixed fee, $23. That's the meter charge. And so the thing about this meter charge is that solar is not going to offset this fixed meter charge right there. And just remember, they might call it something else. It's a fixed fee. It's just for being connected to the utility. You would have to cancel your utility and just go totally off grid to get away from that one. And so, yep, you could try to argue that solar would work for that. Did you know that in some places it's against the law to disconnect from the utility? Like if you just wanted to go off grid and get batteries and everything and not have the utility, it's totally against the law in some places. That just does not seem very American. I mean, what if you just said, I don't want to use electricity? You can't, you still would have to have some meter charge. Yeah, we know who's paying the politicians. And then what we're looking at here is electricity consumption is what they're calling it, but this is kilowatt hour. So this is consuming the electricity. Then we have demand charge on and off peak. And then we have delivery charge for energy and transmission charge for energy. So we can see that this is different than that. So in this article, I just took a screenshot, but we have different numbers. So there's something different here. However, we can see that they broke down the energy into different things. So part of it is for the electricity, part of it's for the delivery, and part of it's for the transmission. Like, what's the difference between delivery and transmission, huh? Well, they've got it figured out. So perhaps transmission is over longer distances and delivery. Anyway, there's a lot of crossover there. And I'm sure you can go and read the fine print on their bill like everybody, I mean, nobody does, and figure out the difference between delivery and transmission. But you know what? It's not going to matter because people are going to have to pay it. In fact, it's probably just makes more sense to just have it be one thing. And we could see that a majority of this charge, we're talking like 16 cents, then we're talking 0.6 cents and 0.2 cents. And so both of these delivery and transmission are less than 1 cent per kilowatt hour. Mostly you're getting charged for that electricity. And you can offset all of these kilowatt hour charges. They all go together. You can see they're all for 23,245 there. So when you make a kilowatt hour, it lowers this by 1 every time you make a kilowatt hour. And remember too, there are thousands of different utilities in the United States, and every utility has many different rate structure. So I would say there's probably like tens of thousands different ways to bill people in the United States. I would even bet that there's probably some person that has their own special rate schedule. But I think you kind of get the point here. And so if we go back to this question, demand, energy, meter, and total, let's just look at the bottom one here. There's the total, there's the demand. And remember, we've said it a number of times that solar does not offset demand charges. The reason for that is because you can have demand when the sun is not out. And perhaps it does offset them slightly, but NABCEP wants you to know that you should not go around telling customers that solar is going to offset their demand charges, because that has given solar a bad reputation over the years, because many solar salespeople have gone out and told people that solar was going to offset their entire electric bill. And they would be people that had demand charges that they told that, and it's just not the truth. So don't go promising demand charges, but we can offset only the energy charge with our solar. That's pretty much all we're doing. We obviously don't offset this basic fixed meter charge, and the total charge, we can offset the part of it that is the energy charge. And here the energy charge is 3 different things, everything for kilowatt hours, which are energy, small k, capital W, small h, which in this case is somewhere around 17 cents a kilowatt hour when you add all these things up from this lower box here. So the correct answer, you've probably already figured it out, is B, energy charges. Here's just another screenshot, and we have this one calling it a base charge. And this was something else I just pulled off the internet. And so that's the meter charge that we have there. There's the energy charge. We can offset that one. Fuel cost adjustment. Maybe they're charging them because the price of coal went up, something like that. Who knows? Like I said, there's so many different utilities, and they can all have their own weird things to trick you out of your money with. And so here they're calling it the customer charge, the base charge, the cost of things like meter reading, billing, accounting, all those things that are not for the energy. And of course, the energy is for kilowatt hours, kWh. And then you can see that's what meter readings are too. So perhaps what we have here is we take 98114 and subtract 96434, and we would get 1680. Go ahead and try it. That's what it should be. So anyway, what solar is going to offset is the energy charges. What energy storage is going to offset are going to be more like demand charges if you're doing commercial, but also you can have different energy charges for a house, such as energy charges are different at different times of the day, or you get less money when you export. And this is a variable that you see all over the place. You know, you have to look at a particular bill to see what that is. So batteries also work when energy charges are different. So let's say that energy is more expensive in the evenings when the sun is setting. And so you can fill up your battery in the daytime, and then you can use that energy when it's more expensive. And another thing too is you can fill up your battery when you're at home. You can fill up your battery when you're at work and there's nobody using electricity at home and it's noon and the sun is peeking out. You're filling up the battery rather than exporting because you don't get as much to export. And then you can use that energy later in the evening. And that is something that people do with batteries. So batteries are good for that and for demand charges. But solar by itself is mostly good for energy charges because it makes energy. It doesn't store energy. It only makes energy when the sun's out. And so you can't really help out demand charges that well with solar. And they want you to know that. You got it? The answer is the most relevant piece of information for a customer going solar out of all these 4 is the energy charges. With the total utility bill charges, you'd also have these meter charges and demand charges in there, so you couldn't really figure out how to size things. But if you had all the energy charges, that's much better information.